Upper team, what are you doing here? Been here almost 2 weeks. What's going on? Hey, upper team. Hey, have you been sleeping in a copian at AEC for the last 2 weeks?
Oh man, been trying to study for the statics final. I need to get that A, man.
That is important.
Yeah.
But you also need to get out and play some ball or something. I mean, like, this is not a life. Look at this. This is terrible.
I know, man, but I won that A, man.
Yeah, well, let me tell you. Here, you can study a little bit more. Have this Coke. It's going to revive you. Take it, all right?
Sure,
it's
man.
my present to you. Whoa, whoa, whoa.
What the hell is going on here?
You're not carrying it?
I can't carry this out. What
Here,
the?
let me help. I have to call the doctor. This is very serious.
What's going on?
Hello, I'm Dr. Reich, and I'll be examining you today. What's bothering you? Oh,
My hand, it's just...
oh man.
Oh.
Let me look at your arm.
Oh.
Well, young engineer, this is not an uncommon problem. It commonly ails young Lafayette students near finals week. It is called soda cannot lift it to my mouth of cola. Now, it's not too serious, but if not treated early, it can lead to paralysis in the muscles, stiffness in the joints, and possibly an F in the course.
Oh my God, an F in the course. What do I do, doctor?
Well, not much. Let me see. Please, push against my hand. Push, push, push. Oh, okay, okay. And let me see. Well, it seems it's pretty serious. I think max weight for your bicep, 45 pounds. I wonder if I could hold a 5-pound bar of chocolate. Would my bicep be strong enough? That sounds like a statics problem. This is statics problem 5-21, and it states, when holding the 5-pound stone in equilibrium, the humerus H, assumed to be smooth, exerts normal force Fc and Fa on the radius C, and ulna A is shown. Determine these forces in the force Fb that the biceps B exert on the radius for equilibrium. The stone has a center of mass at G. Neglect the weight of the arm. Okay, we're starting with a free body diagram. So we're given the weight, which is 5 pounds, and that acts at 14 inches from the origin at point A. And we are trying to solve for 3 forces. First, Fa, which acts in the negative y direction at point 0, 0. Then we have Fc, which acts in the positive x direction at a distance of 0.8 from the origin in the positive x direction. And lastly, we have force Fb, force of bicep, which acts at a 75-degree angle to the horizontal at a distance of 2 inches from the origin. So first, we're going to start by solving for the moment about point B, using the moment being in the positive direction going counterclockwise according to the right-hand rule. So we're going to start by finding the sum of the moment about point B. So you have the moment about B is equal to 0 because the system is in equilibrium. And now, according to the right-hand rule, that is going to be equal to the force of A times the distance of 2 inches minus the weight of 5 pounds times the distance of 12 inches. Now, Fa is equal to negative 60 over 2, or positive 60, which is also equal to 30.00 pounds. So now that we have solved for the force of A, we're going to use the summation of the forces in the y direction to solve for force of B. So now we're solving for the sum of the forces in the y direction, which is equal to 0 because the system is in equilibrium. Now according to our axes, that is equal to the negative 5 weight, negative 5 pounds, minus force of A plus the force of B times the sine of 75 degrees to find for the y component of f of B. Now that is equal, or f of B, when solved, is equal to 36.24 pounds. So now that we have solved force A and force B, we have one unknown left, force C, which we can solve for using the summation of the components in the x direction. So now we're going to solve for the summation of the forces in the x direction, which is equal to 0, because the system is in equilibrium. And that is going to be equal to the force of C minus the force of B times the cosine of 75. And this gives the force B component in the x direction, which means that Fc is equal to 9.38 pounds. In summary, we found a force A at the joint of 30.00 pounds. We found an Fc as the horizontal component of the joint at 9.38 pounds. And we found Fb, the force of the bicep, at 36.24 pounds.
Oh, look at this. I can lift this 5-pound bar of chocolate again. Yay, statics!
What are you making there, Jack? Chris, what are you making?
Tacos!
What did you say?
Tacos? Oh, it's a sombrero man. He wants tacos.
That's what he's saying.
They're all those tacos.
Me gusta tacos.
Sombrero man.
Got another funny guy over here.
Yeah, I'm a funny guy.